YouTube. I always watch these recordings later just to critique myself, and then I realize I'm looking around like a squirrel. That's because I have this big monitor. I'm trying to figure out if I'm live or not on YouTube. I can hear
It
an
always
echo.
happens
Sorry.
from my side.
Oh no, I was gonna say I can hear an echo, which means I'm live on YouTube and I can hear myself.
Okay. Yeah.
All right, awesome. Let me share my screen and get started.
Sure.
Hey everybody, welcome. Thanks for joining us on a Saturday evening, morning, or Friday evening, depending on where in the world you're joining us from. Or if you're watching the recording, thanks for checking the recording out. I am excited to be hosting Sahil and Nikhil for CTDS 2.0. That's what we're calling Chai Time Kaggle Talks. I'll give an introduction about the session, then about our guests, and we'll quickly jump into learning about their journey and the solution. So, quick heads up if it's not quite obvious from the banner, we'll be learning about the fifth position solution from the ventilator pressure prediction competition. Sahil and Nikhil's team called CR7 is the GOAT. Some of you may agree, some of you may not agree. I'm not a football fan, I just know what that means. Won the fifth position medal, and we'll be learning about how did they come up with the solution, how did they get started on Kaggle. Both of them are Kaggle masters, and how did they become Kaggle masters. So as a reminder, please ask all of your questions here. It's quite tough to keep an eye out in the YouTube chat, and if you head over to this link, it should take you to our forums. You can simply reply with your question here. And towards the later end, we'll keep an eye out for all the questions. Let me post this link on the YouTube chat as well. Awesome. So for the agenda, this is CTDS 2.0. I've gotten a lot of feedback where basically everyone wants to learn more about code solutions, learn more about how did the solution come about, and also cover how did the guest reach to their point in the career where they are. So that's what we'll be doing, as I mentioned earlier. Most of these are live and are deep walkthroughs of the solutions. So first of all, I'd love to introduce Sahil Verma. He's a Kaggle competitions master. As you can see, he's ranked currently on 385 out of the 171,000 people globally in the competitions ranking. He's also Analytics Vidya's current #2 rank holder and works as a data scientist at OK Credit. Sahil, thanks for joining us.
Thanks, Sam, for having us. Thank you so much.
I'm excited to dive into your journey, and I know we'll be learning a lot more about that. So I'll hold my questions for another minute. Nikhil is a Kaggle competition master as well. I believe both of them got their recent gold medal, which moved them up to competitions master. You need 1 gold medal and 2 silver medals. Nikhil has 3 silver medals already. He currently works at Karma Life AI, and if you go through his LinkedIn profile, you'll find at least, I ran out of counting, but you can find a lot of competitions where his team has performed really well on platforms like Zindi, Analytics Vidya. I saw competition related to AWS as well. Nikhil, thanks for joining us.
Thank you, Sanyam, for having us.
Super excited to dive into your journey, and I'll stop sharing my screen and start asking my stupid questions like I always do. So, first, I always start with this question: how did you discover data science, and how did you get started on Kaggle? Maybe I'll start with Sahil. You graduated from IIT in around 2016.
Yeah.
My college friends, I started my college journey in 2015. In India, no one knew about Kaggle at that point. Was it the same for you? How did you discover Kaggle?
So Kaggle for me, I discovered it at my stint at ZS Associates. So there I was working as a data analyst there. But there was a group which used to like a group of data analysts who used to come together, which was being supervised by a couple of managers who were also inclined in data sciences. And they used to work over the weekends on different Kaggle problems. I still remember the first Kaggle problem that was discussed there was Instacart from 2017. So that was the first time like I saw a group of people working towards Kaggle. I had heard about Kaggle, but never had this like inside of me like to find out what Kaggle is all about. But that group helped me discover Kaggle and basically got me interested into data sciences. Yeah.
How was the scene earlier? Like it's a few years earlier now. You can find all of these resources to get started. How did you go about learning all of those things?
So for me, the first couple of competitions I couldn't even enter. Like there is this inertia which the beginners like. Even right now, people might be starting out with a certain inertia. Like it's very difficult to like to see your public ranking not being there on the top, even though you yourself know that you don't know anything much about the data science world. But still, that feedback that you get from the LB, that is quite scary in the first go. So it even now also, if you see the I barely have participated in 10 to 12 Kaggle competitions till date, and that inertia is still there with me. Like some amount of inertia is still there. But for me, the critical part was trying to learn from the public solution, even though you are not participating. So what beginners try to do is try to submit a public kernel and get some rank. Maybe they might even get a bronze or a silver medal also. But the learning part is not there. So what I tried to do was, even though I was not participating, uh, like I said, I have only participated in 10 or 11 competitions, but I would be knowing about all the competitions that are happening on Kaggle, and I would be actively going through the discussions, because that discussion, that rich source of information that is there in the discussion, like that is the gold mine of Kaggle, I feel. So for me, when I was starting out, uh, I didn't participate in Kaggle, but it acted as a learning guide for me, and because of which I started competing on other platforms where I felt that to get early success was relatively simple as compared to Kaggle. Like to get that initial feedback, which got me more interested into competitions. So for me, like it was a mixture of both. Like Kaggle was a learning guide for me in the initial phases.
That's awesome. I'll probably come back to this question again, but Nikhil, I'd love to know about your journey as well. You've just graduated recently. Did your college friends know more about Kaggle? I really hope they did. And how did you discover Kaggle? How did you get started on Kaggle?
Yes, so thanks for the question. So basically, I started my college in 2016, and my ML journey started from the beginning of my second year, right? So there was one of professors of ours who was working with us extraterrestrial life discovery, right? So basically, life on other planets. So he was using ML for that, and he was giving us a webinar. So that got me really interested. Like, what is this thing? Like, we can use it to do so many cool stuff, right? And then I gradually searched on internet, like, how do you get started with ML and stuff? And then I came across the famous Andrew and GML course, right? So I just got started with it, and then the journey began. And for me, it's always been like, whenever I try to learn something, I participate in competitions. So firstly, when I was thinking of like how do I practice what I've learned in ML, I came across different platforms, notably Kaggle, right? So in platforms like Kaggle, the biggest thing I feel is in a short amount of time, you get to try a lot of different things, right? So for me, I think just 2 months or 3 months after I completed my first course on machine learning, I started participating in competitions. So I think the first major competition I participated on Kaggle was, I think, Porto Seguro competition, right? So I did really bad there, but then again, I got to learn a lot of things. And yeah, so many Indian platforms like Hackeratan and Analytics Vidya have also been there. So I'd just like to mention, like, when I was just starting out competitions, I used to see Sahil getting really high ranks, like in Analytics Vidya. So again, he was also a source of inspiration for me that, like, you can do well in machine learning competitions. Yeah, the journey for me in Kaggle and different competitions have been like this.
That's awesome to hear. I also saw that you have teamed up with Sahil earlier as well. But question for both of you: how did once you discovered these platform, and there's always this hesitation to me. I basically retired since I know I can't get another gold medal, and that also happened because of a great team. I don't think I'll compete again out of that terror. But once you start competing, how did you make a conscious decision to improve? Sahil, you said you were going through solutions. Did you try to re-implement them? How did you try to improve?
Yeah, so this is like the most critical part. Like, even if you don't perform well in a competition, or let's say you were just a bystander in that competition, you were observing a competition, it's really important to understand the top solutions. Like, it's the most common. If you ask any of the top Kagglers, this is what they would also recommend. That try to implement the solution that people discuss in the forums on your own. Like, it's good that you are able to understand a kernel or maybe some form of discussion, but that once you implement a thing, that sticks in your mind, and you would be able to use those solutions later on in the competition. For example, many of the tricks in this the competition that we used were taken, like, some of the inspirations were from past competitions. So yes, this idea that you need to implement the solutions on your own is like the way to go about improving your Kaggle skills. Yeah.
Nikhil, do you want to add anything?
Yes. So I think from the beginning of my data science and machine learning competitions journey, so what I see is that if there were no solutions from the people who did really well, I think many of us would not even be able to progress that further, right? So I think I read solutions from, say, Sahil's competitions in which he did well in, say, analytics Vidya, and there were many other competitors, right? So I think it's very important that you go through these solutions. So they help you think from an other person's perspective, how they go about problems. And yes, it's always good to uh, keep learning from other solutions and trying to implement it yourself. So yes, the answer is quite similar from my side too.
Yep, that's very practical advice. And what I'm hearing is you should jump onto competitions also as soon as you can. I have a book on introduction to the standard ISL, ESL books, but I'm never going to read stats in the foreseeable future. When should one start competing, in your opinion?
So I think
Yeah, yeah, go ahead,
sure.
please.
So I think as soon as I did my first course, I participated in machine learning. Even though I did not get a good rank, I learned a lot about it. So I think you should not fear going there and start participating in competitions, even though I don't get a good rank, right? So even now I just participate in some competitions just so that I get a flavor of a new field, right? So a new era. So maybe some kind of, say, image segmentation competitions or something maybe which I have not explored. I want to go there and try something. Even though I don't participate actively, I'll try to participate passively and try to learn from what people are doing there, right? So I think it's very important that you start participating in competitions. It's not like I've also been asked this question many times on LinkedIn, that when participate in competitions, like should you wait for a year or two or become too much confident and then start? So it's not like that. You start and then the learning will always be there. It's like it's continuous. You just can't jump steps. That's what I feel about it.
So just a point to add here. So there are generally, when you come to Kaggle, there are two schools of thought that we have already seen being discussed on different social media platforms, that Kaggle is beneficial or not. So to any beginner, what I would suggest is, so there are two things that you can learn from Kaggle. One, one is the obviously the modeling related things that you get to learn, and second is the competitive spirit that it builds inside of you. So that is something, this is something which I believe that if you experience it the first time, you would continue doing Kaggle for the rest of your life. We can even see, like, people like CPMP, like, they have, like, given so much experience they have, they don't even require to do Kaggle, but still they are like getting great ranks, doing really well, coming up with innovative solutions. So what I would suggest is, as Nikhil said, get into a competition, give it a good go, and post that, you would have that you would get that feeling that whether you would want to continue with Kaggle or not. Like, um, this so even for me now, if I enter a competition, even though the rank is bad, but that the drive inside of me to get that rank upwards is something that I really like. That is the best feeling that I get from Kaggle, apart from the learning. So as I said, that there are two things which I think decide whether you would continue on Kaggle or not. That competitive drive is really an essential thing. I believe Nikhil is also the same. and most of the top Kagglers are. If they try to participate in a competition, they will try to drive that rank up, and eventually that is how you also learn. Yeah.
I found roots to competitiveness in both your profiles. Sahil, you ranked up, I think, somewhere around the 700 in India as one of the most difficult papers, which requires you to get into IIT. From there, also in CAT, you ranked, I think it was like a really high percentile. And same for Nikhil, he's ranked really well across different data science competitions. So I think that's where both of your roots on Kaggle come from.
Yeah, so that competitive thing is something I feel that if you have, you will get like hooked into Kaggle. That is for sure.
Awesome.
Yes,
So
exactly.
one more Kaggle related question before we start diving into the solution. Both of you are from India, and we've seen. I'll point the platform out on LinkedIn. This constant debate of if Kaggle is useful. Have you found your Kaggle achievements relevant to employers, or how do you
Yes.
present them when you're
Yes.
talking to an employer, for example?
So yeah, I'll go first on this one. So basically, uh, in my college, it's not like companies don't even come for say data science placements or something, right? So people always come from say if you want to become a software developer or not. So for me, that was a really challenging journey because I really wanted to become a data scientist from the point I started this data science. And I believe Kaggle has been the most important factor for me uh, in this journey, right? So Kaggle or any machine learning competitions that I participated in, that really helped build my profile. And then I started building connections, and then I found great people, including Sahil, and I have competed with many people, right? So in Zindi, I competed with people from Africa. I also competed with people from France, Australia, and different countries. So what I felt that when you participate in machine learning competitions, you build a lot of connections, and many of these connections have been helpful in me getting a data science job and growing in my career. So I think if Kaggle or machine learning competitions was not there, I would not have been here first of all. So I would be doing some software engineering job. Software engineering is great too, but yeah, for me, like if I wanted to become a data scientist and I did not have a machine learning competition platform such as Kaggle, I would not be here. So yeah, I'm really thankful to Kaggle and all of the data science community out here.
Yeah. So I believe that there are two sides of story here. So as you said, Sanyam, that people generally like it depends on which company you are applying for. So specifically, in if we talk about India, you generally find two kinds of hiring managers, like the people who come into touch with you and try to hire for a data science role, right? And they would
The
be again
ones
from
who
the
are super secretive, who ask you to send your resume and don't tell you about the job unless you hop on a call with them, as if they're dealing something illegal.
Yeah, I face.
yeah. So again, the two sets of people, again, they are from two schools of thought that Kaggle is useful or not. It really depends on them whether they feel that Kaggle achievements which you have listed on your resume are going to be useful or not. What Nikhil said is absolutely makes sense, that the community that you get from Kaggle eventually might help you land a much better job. Might be in India or might be outside. Like that is one of the like the true potentials of having a good data science community. But what I feel that if someone who is not from that community, or if he's not from that background, there are many people in India who are still not part of the Kaggle community, and even if they have heard of Kaggle, they don't find the value there. So in that case, to justify that getting a good rank in Kaggle is a really difficult thing, I think like it's difficult for them to understand how much effort it takes to get even the a bronze medal solution also, for say. Like that is really difficult for them to understand. Yeah. And also one more thing that I would like to add. Sorry, man. I forgot what I was going to add. Yeah. Sorry.
No worries. I I guess my interruption must have derailed
No,
the
no, no,
thought.
no, 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 no.
But no, from in my experience, I totally agree with you, and you probably wouldn't want to be at a place where they don't respect Kaggle as much if you're really a Kaggler, because if you work at a place where people understand Kaggle, you can simply tell them that, hey, I'm going to spend some time on a competition, and they'll absolutely respect the time that goes into it.
Yeah.
Other places might not appreciate even how difficult it is to get a silver medal, for example.
Yeah. So the point that I was going to add, Sam, was that even though these two people are from two different school of thoughts, what is necessary for people to understand is that a simple example like importance of cross validation schemes. This is not something that you are going to learn in your real life projects. Like that is just a small part of the pipeline. So it's
Yes.
important for them to understand it's not just about the ranks. It's about the entire process that we understand when we are competing in a competition.
Absolutely. Awesome. I'd love to dive into the competitions bit. Before that, does anyone of you have anything to add from your journey or any point that I missed?
No, I think, yeah, we can go to the competitions part, I think. So,
Okay.
Sahil, you want?
No. We can continue.
Awesome.
Okay.
Let me share my screen. And I'm insanely lazy. So instead of preparing an EDA kernel myself, like I should have, I just find ones that I can understand and walk through real quickly. That's what I like to do. And I usually start with the description. So the competition, just to again point out to the audience, is Google Brain Ventilator pressure prediction. And if you go to the leaderboard, you don't have to scroll too much. You can find both of our guests right outside of the prize zone. I'm not sure if being two places under it is more hurtful or fun place.
Yes.
I can imagine. But coming back to the description, from what I understand, you're required to simulate ventilators, and we'll just talk about what ventilators are. And this was to help reduce the cost barrier for developing new methods. So this was literally something that's real close to providing human value. And I found this kernel called ventilator pressure slash LSTM starter that gives this nice outline. Ventilators, to those of you who don't know, are used to provide life support to someone who's having trouble breathing. They're usually sedated and can't breathe themselves. And ventilators helps pump air into their lungs. Essentially, this is how they function. And from what I understand, we were trying to optimize this process, correct?
Yeah.
Yes.
Now, continuing my laziness, instead of going to the data tab, I'll use this kernel called Ventilator EDA by Ishan Datta, who's also created a WNB dashboard around it. I just wanted to quickly point out the different columns that exist in the data. So you can see there's a global identifier for the entire file set. You can find breathe ID, and this was to measure different breaths, as I understood. So every single breath that the patient was taking had a different timestamp attached to it. So this is for identifying that. And Nikhil and Sahil, please, since I haven't competed, please feel free to interrupt me anytime I'm wrong.
Sure.
Sure.
R stands for the lung attribute, and this basically indicates how clogged your breathing pathways or how clogged your lung is. I tried to Google a bit, and this is one of the standard units in which it's measured. I won't bother explaining it since I'm not an expert. C column tells you the lung attribute, indicating how compliant the lung was. And you can find the timestamp, the input, control input for the solenoid valve. And now, if you try to Google this again, you'll find more details around ventilators and all those things. I'll try to skip those details, but long story short is it gives you the control input and output, and pressure points out the airway pressure. Anything that you might want to add here?
No, Sam. This looks good. Yeah.
Yeah, this looks great.
And now continuing on my laziness, I'll shamelessly use the plots by Ishan to point out details in the data. I'll post this link again on the forum thread I'd shown. So any of the links being discussed today will be posted on our forums. So please check there if you're curious about anything. This plot shows the comparison against density versus R. And just to remind everyone what R was, it was how restricted the airway inside your lung is. And a similar distribution of sort is visible for lung compliance. Control input, I guess this sort of makes sense because you probably wouldn't want to blast a lot of air or very dense air into anyone's lungs. So it usually hovers around a smaller set of values. And I couldn't understand this. Maybe Sahil or Nikhil, you could add here, but I couldn't understand why there's so different values for the out densities.
So UN was more of a continuous spectrum which was provided to us. If you look at the values of UIN, the input control variable, it was more of a in the continuous form. Whereas for UOut, we were given a binary flag. It was an indicator variable, which indicated
Yes.
whether the air that is being flown into flown into the lung, is it like going out or not. It was just a 0 or a 1 flag. Like
Yes.
when you
Yes.
inhale, that is how it is defined as like the inspiratory phase and the expiratory phase. When you inhale, you are not like the air is not moving out of the lung. In that case,
Hmm.
your U out would be equal to 0. And when you are exhaling, that means that the valve is open now. It's an indicator variable. It becomes 1. That means now you're exhaling. It's in the expiratory
Yes.
phase.
Yes. Yes.
Okay,
And
sorry,
yeah.
please.
Yeah. So, and you are, and you could also see that in many of the cases in the expiratory phase also we had positive values for UN. So that was basically used to reset the lung, right? So uh, the U out, the UN values for the expiratory phase were kind of hard coded, so you can reset the lung, and then you can start a new experiment with it.
I guess if I were to like plot these on top of
Mhm.
each other with the same timestamp, this would be more visible there.
Yes.
That makes sense. Thanks for that clarification. And to the audience, I'm sorry, I'm talking more than our guests, but my promise to them offline was I'll do more of the prep, I'll do more of the walkthrough so that they don't have to do much preparation. That's why unfortunately you have to hear me walk through the EDA. Sorry about that.
Sure.
Um, so I think the airway pressure is quite clear. I'll continue scrolling and
So just to understand the RC combination, you were on the right plot, Sam. We can go down a bit.
Mhm.
The actual, if you want to understand the significance of RNC, you can look at it this way, that my set of lungs would be very different from Sanyam's and Nikhil's. So these combinations of RC actually influence how your basically your lung is going to expand or basically compress to the different flow of air. So different combinations of RC can be seen as different set of patient lungs per se. So yeah, these actually play a like sort of an important role while modeling. Yeah.
That makes sense. Thanks for that clarification. I guess, but there's still some pairs, right? And I'm guessing people would fall into similar buckets. That's what's visible here.
Yeah. The train and test distribution were very similar. Like if you see,
Yes.
and that makes sense as you said. Like yeah.
So Ishan has done an amazing job, which is why I can continue just working through his notebook and instead of
Sure.
checking out
Sure.
another notebook. The
So
next thing is,
just
sorry.
a quick point here. So if you look at the data is not very complex. Even if you look at the
Mhm.
number of columns, the size of the data, it's
Mhm.
not huge. The number of columns are not very large, and you can easily understand like what is happening and do a simple EDA. And this was probably one of the reasons that we started out with, like, why not just try this competition, given that the data set size is also not very large. So this was one of the like the decision making points based on which we decided to enter this competition.
Thanks for that. This is just a feature correlation plot of all of the different data points or data features that exist in the training data set. Um, I'm just trying to see how is this highly correlated, but this sort of makes sense. You out would happen at regular intervals, I'm guessing, which is why we see a higher
Yeah,
correlation.
So
so
you
U
are.
out is 0 and 1. Yeah. So for
Yes.
a
Yes.
certain
Mhm.
starting n time steps, you have the inspiratory phase, and post that you have the expiratory phase. So there would be a very high correlation in that.
Yes. Yes. Yes.
Okay. If I can understand the rest of the graph, I assume the audience can as well. So I'll continue further.
Sure.
And we do the same for the test data. The same is visible here as well, almost, which means like Sahil said, there's a nice balance amongst both the training and test data set.
Mm-hmm.
And here's a plot of variation of pressure and input valve position during the first versus second breath. And it just, maybe I'm wrong, but to me it was quite clear that this just shows the slight shift amongst the time steps. And same for breath, as to me it was quite visible that the graph is just shifting along the x-axis a little. Is there anything else that we can learn from it?
Yeah, so just one
think-
point that Nikhil. Yeah, Nikhil, please go ahead. Please
Sure.
go ahead.
No. Sahil, I just wanted to point out that he has Ishan has taken the x-axis as the ID, so he's plotting multiple breath IDs together. So yeah.
Okay. Yeah.
So we
Sorry,
have-
I overlooked that.
Yeah, so for each
Yes,
breath,
Sahil.
we had 80 time steps. And if you could look at the go out part for, so basically what happened was we were given around 30 to 35 time steps of the inspiratory phase, and remaining time steps were of the expiratory phase. And what you
Yes.
could see was there's a sharp decline, like a drop in the value of the I is the U in plotted here, or is it just the pressure?
I think it's just the pressure.
No,
It's just the
UN
pressure.
is not plotted. Only
Okay,
ID versus
okay.
pressure is plotted. Yeah, so ID is just the different breaths that we have.
Yeah, cool.
But
Cool.
thanks for that clarification.
Yeah.
From there, Sahil, sorry, Ishan talks about the architectural needs, and I'll probably just skip that. Now, coming to the competition, I was gonna ask, and you've already shared the answer. But at what point did both of you decide to team up, and how did you start approaching the competition? So, what I'm trying to understand is, when either Sahil or Nikhil, when you saw this competition, how did you create a baseline? What was your baseline?
Yes. So I think we both had participated together many times, right? So in different competitions. I think this was the fourth or fifth competition we were participating together. So yeah, when we just saw this competition, we both wanted to become Kaggle masters, right? So it was a kind of eternal challenge between us, like let's see who does better or something, right? So we all both started. So Sahil, I think, had a lot of office work, so he started out a bit later, and then I had started, I think, from the first day or the second day of the competition itself, right? So regarding the baseline, I think it was mostly the public kernel. So I think firstly I started with, I liked GVM and XGBoost. I don't know why, and I thought that maybe I can try this and get a really high score. Then for the first 1 or 2 days I started with this only. So I saw that the data is not as huge. So I think I can start with some of the common structured data frameworks like GVM, right? So I started with that, and then I slowly shifted towards LSTMs and GRUs when I saw public kernels performing that, right? So this is one more benefit of the Kaggle community, that you get public kernels, right? So even if you are a beginner and you don't know how to approach problems, these public kernels are really helpful to you. So I started with that. And yeah, just one more point I would like to add. So uh, I had used transformers, but I had not used them in this for time series competitions, right? So again, this was one major reasons for me entering this competition, right? So I wanted to just try out how transformers work for time series data, and then I saw that the data size is not that huge, and it looks kind of neat and kind of easy to work with. So yeah, let's give it a go. Yes, I.
Yeah, so I also started, like, when I saw this competition, the first thing that came to my mind were the different front end that I would eventually use in this competition. Like, if you see a 1D series data, sort of the first thing that came to my mind was I just listed out my things. I'm going to use sequential, like RNNs. I'm going to use 1D CNNs, transformers, conformers, whatever possible. And the first attempt was again, I guess, the LSTM one, if I remember correctly. And one of the early patterns which you could see that most of the kernels were in TensorFlow. I'm a PyTorch guy, so you could clearly see, yeah, yeah. So, but you
I
could
was
clearly
waving
see,
my hand in happiness for the audience
yeah,
because I
yeah,
love PyTorch as well.
yeah.
Sorry, Sahil.
So, but you could clearly see the difference in performance from the get-go. There was like, and it eventually turned out to be an initialization issue. But the because of that issue, and we are talking about Kaggle margins, that was an issue. So I struggled a bit in the beginning to get a good enough baseline that would get a decent enough rank. But again, the model was driven by what was there in the discussions. That is like LSTMs. Yeah.
That makes sense. So just for my own understanding, I'm always curious, how do you find ideas from there? Is it just based on discussions, or are you also trying to find papers that somewhat relate to this, maybe from older competitions? How do you go about that?
Yeah.
So
So
I think, yeah, Sahil, you want to go first, please?
no, no, Nikhil, please continue.
Sure. So for me, I think got a lot of ideas from participating in different time series competitions, and how people approach things, right? So these were the ideas for me. And then again, if you start a new thing, basically the first thing I do is I try to read a lot of blogs about it and a few papers, right? So I basically hit Google something like state of the art method for time series, right? So I hit Google like that, and then I see a few papers, and say when I was starting with transformers and my transformers were not converging, I just hit Google for how to converge transformers faster, something, right? So I came across one paper that we eventually utilized at the end of the competition, right? So I think for me it's a mixed bag. So obviously there's a lot to take from different past competitions, and when you're trying out new techniques, you can obviously Google and see what are the state of the art methods for the things that you want to do.
Yeah, same for me almost. Like, it's not a single shot solution. You need to try to experiment with multiple sources. So, one tip is like if Heng Sik is participating in a competition, it will make your life easier.
Wait
Like
for his
his,
presentation that's highly annotated, and he also creates
like,
arrows pointing toward different code snippets too.
Exactly.
yeah, like
Yeah.
so for him, like that is my dream scenario. That even like someday in the future, I would be taking my Kaggle competitions in such a setup. Like, there should be mini research projects wherein you have your working notes and people could refer to them. Like, even like for me, the process is really messy right now, but that is like the ideal scenario that I would like to see myself in someday. Yeah. So first is like discussions from such reputed Kagglers who have a demonstrated history. Like they come up with various solutions, innovative ideas, and they even link the papers that they read through to get to those solutions. So reading upon those past solutions. So again, in this particular competition, given the nature of the data and the recent increase in the number of audio competitions, it was really straightforward that you could just look at the solutions from the audio competitions also, like what kind of front ends they were using. And it actually helped us like in one of the things that we tried in our solution also. So it's a mixed bag. You need to go through multiple uh, papers or multiple discussions. One thing we missed in this competition was going through the paper that was quoted by the organizer. So we didn't
Yes.
go through that. Maybe if we had gone through that, we might have ended up in the money zone. Who knows? But yeah,
You still landed good though, so pun
yeah.
intended. That's incredible. Um, Now continuing to your solution, I believe you have a presentation. Would you like to share your screen,
Yes.
or I can? Okay.
Yeah,
Sure, sure. Sahil will share his screen.
yeah, I'm sure. Cool. So I'll skip over the part that we have already covered, right? We have gone
Mhm.
through the problem statement. The input data we have already looked at. So just a brief of the solution summary that we are going to go through. So we are going to go through some of the key features of our model, the ideas behind the problem setup we had, and validation strategy, and finally the transformer that we had built, and and obviously the things that didn't work in this competition. Uh, yeah. So
Sounds good.
yeah, just yeah. So as seen in the data, for every breath, we were given 80 time steps. Like each breath was being defined by 80 time steps. But the question that we can ask ourselves is, do we need those 80 time steps? Do we need the entire full data? As we could see that since the metric of the competition was also MAE on the inspiratory phase, we tried this experiment that where we removed all the breath, all the timestamps which were from the expiratory phase. So doing EDA, what we could find was the maximum length of the inspiratory phase for any given breath was of around 35. Like 35
Hmm.
time steps were from the inspiratory phase. And this varied from different breath IDs to breath IDs, but this was the maximum length. So to avoid padding, what we thought was let's truncate our entire sequences at the first 35 time steps. The idea again behind that was driven by the kind of metric that our models were going to be evaluated on. So what we decided
I'm
was
guessing that would also help the training time and cut it down
yeah,
by quite a bit.
exactly.
Exactly.
So that was like the major advantage, and we will come to that. So we decided to work with the sequence length of 40, and what we saw that we got slightly better and mostly comparable performances given the some noise would like noise in performance, but mostly comparable performances. But the major boost that we got was from the training times. Like we were almost able to halve the training times, which eventually, if you look at our solution, that was one of the necessities of our solution, that the models had to like we wanted to train more number of models, and eventually model had to run for a longer period of time. So yeah, this was like the one of the core ideas of our solution, that using only the first 40 time steps and just truncating our solutions sequences to that length. Yeah. Now, this started out as a regression problem. Like if you see the output variable, it looks on the face value that it's a continuous variable. Why not just try a regression based solution here? And all our initial baselines, even in the public forums, this was driven by that fact. And people started out building regression models. But if you look closely into the distribution of the output variable, what you could see that even though it looked continuous, it was a discrete variable. It had only 950 unique values, and
Hmm.
these values were also like the delta between the unique values was also a constant step difference. Like it was d1 plus delta d plus the second value would be d1 plus 2 delta d. So only 950 unique values. So we thought let's try a classification approach. And what we found out was that uh, we were able to achieve slightly better performance, but the major advantage we got from this was that the convergence was much faster. The performance that we were getting, let's say, at 100 epochs from a regression model, we were able to get the same performance in less than 50 epochs. So combining this with the fact that we were training our models only on the first 40 timestamps of the sequence length, and the improved convergence we got from the classification model, uh, this really helped us do much more experiments, much faster iterations, and eventually in the final models that we built, you must have read about the 1000 epochs. So we
Yes.
were able to do that because of these two core ideas. So yeah, these are the two core things that we build our model on. Uh, Nikhil, would you like to continue from here?
Yeah, sure. So yeah, this part I think you might already be familiar with, so I'll not waste time on that. But just for the beginners, it's just how do we validate things, right? So basically, uh, what we did was we split our breath ideas into key different parts, and then for each part we treated it as a test set and trained on the rest of the data, and then we got say predictions for that part, and then we combine all of the training data, and that's how we get our out of full predictions. And if we combine all of our test predictions, we get our mean test predictions. But yeah, for this competition, I think median test predictions work better because again, the metric was mean absolute error. So in mean absolute error, if you try to optimize it, uh, the best will come when you take the median instead of the mean. Yeah. Sahil, can you go to the next slide, please?
Yeah, yeah.
Okay, yeah. So before I go to the next slide, and before I forget, I just like to highlight 2 points. I think I missed them in the beginning. So whenever I do any competition, it's very important for me to do two things, right? So the first thing is to have a very flexible pipeline, right? So one thing that stood out for both of us in this competition was having flexible pipelines. So I really believe uh, at the beginning of your competition, you should spend time in writing your code in such a way that you can modify it easily, right? So it does not require you much effort to change little parts of your code at the end, right? So I think in such competitions such as this, where we had only, I think, around a month, right? So if you can change your code and iterate quickly, that will be a really big advantage for you, because you can do more experiments. And I think in competitions such as Kaggle, where you have to try a lot of unexplored ideas, the biggest advantage can come from iterating quickly, right? So yeah, coming to iterating quickly, what I usually do is I train on 1/10 of the data, and then I can do 10 experiments compared to training on the full data and do only one experiment, right? So I think at the beginning, if you can do a lot of experiments and then come with a good solution, you can always train on the whole data and then get a really good boost on the leaderboard. So what I do is basically I take I split my experiment into two parts. One in which I train on the full data, and one in which I train on only, say, 1/10 or 1/5 of the data, depending on the competition's data size, right? So I track my experiments on that small portion of the data and try to improve on that portion of the data. So once I'm really confident that my experiments are working on that small portion of the data, I go and apply it on the large portion of the data, and then we can obviously submit it to the leaderboard to get feedback.
Sorry to interrupt. How do you track the experiments? This is being live streamed to weights and
Yes,
biases,
yes.
but not as a weights and
Yes.
biases question. How do you track them?
So I'm not gonna lie, but yeah, I use weights and biases for this competition. So before that, I was doing it in a semi-manual way, but yeah, in this competition, I really wanted to try out weights and biases. I had heard a lot about it, and like it lives up to its name, right? So weights and biases, it's definitely a great tool for tracking. So we use weights and biases. I think even Sahil used weights and biases in this competition for tracking. So
Yeah. So for me, life before Bondby was really difficult. I used to track it on Slack, like using a webhook. So
Okay.
for me, that was the way to go. But as you can imagine, that is really a painful experience. And before that, it was like printing out the log, storing it in some log file, and then visualizing the log file. But now, it's really simple, and it's a really useful tool. Like for me, the entire setup is PyTorch Lightning and weights and bias.
That's great to hear. I didn't inform the guest of this question earlier. I just thought of asking this, and it's surprising that you were already using weights and biases. So thanks for the great feedback.
Sure.
yeah, definitely.
Nikhil, please continue.
Thanks. Yeah. Okay, so coming to the feature engineering and learnable front-end part, right? So yeah, firstly to the feature engineering. So I think feature engineering is one of the most important steps in any competition. So yeah, this competition was mostly about architecture and then different other components. But generally, if you participate in data science competitions, I think feature engineering is one of the most crucial steps. But yeah, for this competition, we did not have very complex features. So most of our features were similar to what you would see in public kernels, right? So say for time series, what general features do we keep? One is shifted features. You basically shift your sequences one time step or two time steps, or say n time steps back and get another feature, right? And then we had window features, where you have fixed size windows and then you aggregate your data information on those windows, right? So basically, we can take what is the average u in the last three time steps or the last four time steps, or what is the deviation between it, something like that. And then we also had cumulative features. So one of the cumulative features that was helping a lot was the cumulative sum of the un, right? So basically, your pressure is, even if you think of it intuitively, it's basically controlled by the amount of air that is entering in your lungs, right? So un is kind of cumulative sum of un is also giving you giving your model a similar information to that, right? So yeah, one more thing I would like to point about feature engineering is very important to have domain knowledge, right? So once you understand the problem and why your problem was created and why things should work, you'll be able to create much better features than just trying out random features, right? So I think it's very important that you understand the data first and then try to create features based on that. Okay.
One point, Nikhil, I would like to
Hmm.
add here. So, one very counterintuitive thought could be that we were using LSTMs. They are known to capture the
Hmm.
sequential nature of data. Then why use these features? So, our hypothesis was that even using a single, like even without these features, you could attain a similar performance, but that would take a lot of epoch and longer experiments for the model to reach similar results. So this basically was another thought experiment which helped us accelerate the performance we were able to get in limited amount of time. Like feed in like we knew that there was an inductive bias in the data set given the temporal nature of the data. So we embedded that from the get-go, and this again, that is why you could see most of the public forums also, and the kernels had these set of features.
Yes. Yes. So coming to that, right? So basically, our idea was that features help your model converge faster, right? So this was a learnable front end idea, right? So I think this was inspired from Sahil's idea that he had seen in a lot of different audio competitions. Was that
Hmm.
if you have a learnable front end which actually tries to create features on its own, and then you feed it to the model along with your raw input features, it will help your model much better, right? So basically, what is the how do we think of CNNs, right? So CNNs help capture neighboring information, right? So basically, if you have 10 time steps that 10 time steps near to a particular time step, and then you apply CNN on it, it can aggregate or say create combination of these 10 time steps that you might not be able to do manually, right? So manually we do something like say what is the difference between the last two time steps, or say what is the uh, total total sum of UN we have seen, right? But we do not go for complex combinations. But I think what CNNs help you do is they create feature combinations on their own which they think are useful to the model. And yeah, learnable front end really helped us. So we'll go into detail of how we designed a learnable front end, right? So yeah, if you can see this numerical features, we have a lot of different convolutions, and they are all of different sizes, right? So again, the intuition behind is that we wanted to capture information that is very near to my current data point, and also information that is far in terms of time from my current data point, right? So if you take kernel sizes of 2, it captures the really nearby information. And if you take the last convolution kernel, which is of kernel size 15, it captures nearby as well as information which is quite far away from my current data point, right? So then we concatenated all this, the outputs from all these convolutional kernels, and then we concatenated it along with the raw features, right? So this helped our model do some of its feature engineering on its own. So yeah, that was our idea about that.
So a couple of
And
points
this
here.
was being
Yeah.
sorry,
Sorry.
Sal. This was being fed to the transformer, right? After this front end was being learned.
Yes,
Okay.
yes.
Thanks.
So a couple of
Sahil,
points
please.
here. If on the face of it, this looks like a really simple like front end to have, and the reason behind that was we tried a couple of like complicated architectures like which were done in few of the prior competitions, like ResNet 1D CNN sort of a architecture, but we couldn't really find a performance boost. Like the simple was working the best. And second thing is like the number of channels and the kernel sizes that you would want to use. This could be tuned. Like this is not the perfect architecture we found for this. This is something that was
Exactly.
working for us. Yeah.
Makes sense. To me, it's still quite complex based on other solutions that I would have come up with. So
Sure.
Yes, yes, yes. So finally, we came to transformers, the magic. So it's not like we just tried transformers. We tried a lot of different things, and yeah, Sahil can cover it. But yeah, transformers were definitely the magic for us, right? So basically, transformer has two components: an encoder and decoder structure. And ideally, you can use both of these structures combined together for time series problems. But yeah, for this, we use only the encoder part, right? So I think mostly I did not get time to experiment with the decoder, so we stuck with the encoder part. So did us we did slight modifications to the original transformer architecture. So I'll just quickly go over that, right? So one of the things that we did was RE0 to speed of convergence, right? So basically, when we were doing transformers, we were trying out different things that could help us speed the convergence of transformers, right? So yeah, so again, time was a very big issue in this competition. And what we were seeing in our discussion forums, and even I had posted this as a joke, was that uh, maybe at the end of the competitions people will train their models for 1,000 epochs, right? So definitely the problem was yeah, definitely the problem was the models were not converging as fast as we wanted them to, right? So one of the papers that we really found helpful was RE0, right? So it basically tells that instead of adding the output of a previous layer and the current output, you add a parameter to the which you multiply to the current output, and then you add the output of the previous layer. So thinking of it intuitively, it's basically telling the model to keep only as much information of the current output that it wants to retain, right? So it can even retain more of the current information if it scales the current output by say a higher number, right? So that is basically the idea of RE0. And yeah,
It's
as
sort of
you
like a learnable residual connection that you are setting up.
Makes sense.
exactly. And then as we train deep transformer networks, this RE0 really helped us speed up our convergence, right? So yeah, I'll quickly talk about the key features of our transformers. Okay, the most important thing was highly parameterized and regularized deep transformers, right? So what do we mean by highly parameterized? It's basically having a large number of parameters, right? So even at the end of the competition, I think we did not have enough parameters to train our model, and I think we could go more, but then again we had run out of the GPU limit that we had, right? So
Makes sense.
one big problem with high parameterization is that you need good regularization, right? So otherwise the model starts overfitting very quickly, right? So I think Sahil can tell the joke about the dropout.
Yeah, so basically, the final solution had a dropout of 0.8, but there was this inside joke that was going on that if we keep increasing the number of layers, the number of heads, we might even reach a dropout of like maybe one, like no pass, no information at all. Yeah, but yeah,
I was really curious, but maybe I'm wrong, but like I've never seen such a high dropout value. Like, what
Hmm.
was the reason for like the model still training after having a 80% dropout?
Yeah. So
Yes, yes,
yeah, please, Nikhil, please.
yes. I'll please go after that. Anna.
Good, good. So we feel that so there's this thing that if you increase the number of parameters in your model, ideally you would want to regularize it so that, as Nikhil mentioned, you want to avoid overfitting, and it was driven by that fact. So if you look at the configuration of our final transformers, it had 20 layers, it had 128 heads, and if you compare it with, let's say, a base bird, or even, let's say, large bird, the number of heads and the number of layers, bird, I believe, has 12 layers and 12 heads, or 6 layers, 6 heads, something of
Mhm.
this combination. We had 20 layers and 128 heads. So the number of parameters was such that the dropout had to be high. And again, it was driven by our experiments also. Like,
Makes sense.
in the end, it has to, if it's working, don't fix it, right? So we kept on increasing the dropout, and the performance was increasing for us. Just one point that I would like to add here. So there's this idea that if the data set is small, you won't be able to fit a good neural net model. So given the size of the model that we were using, the data set was relatively very small if you look at the number of parameters, but we were still able to get very good performance because we basically were able to regularize our model by that much. So this belief that you won't be able to fit a good neural net model with a small data set, can be done, but you need the appropriate amount of regularization.
Makes sense. And that's why I was earlier also asking this question. Nikhil and Sahil are both experienced data scientists, and you just shared this experimental framework where you start with a smaller subset and continuously increase it. So you didn't randomly arrive on a 0.8 dropout. I'm sure there was a lot of experiment that went
Yes,
behind
yes.
it, and it wasn't just, oh, let's try a 0.8, let's see if that works.
No, definitely it was not that.
So
Yeah.
Sorry, Sahil, please continue.
one point here. So whenever you are designing your experiments, it's so whenever you read some good papers, there's this section of ablation studies. Try to think it in that manner. Whenever you are competing in a competition, we had a document like a Google Doc wherein we listed out all the parameters that we had to iterate on, all the ideas that we had to iterate on, and the corresponding performance that we got. So that in the end, when you are finalizing your solutions, you also have something to backtrack on. So this also helps. Like doing random experiments will not help. Again, weights and bias again help there also. Like you could eventually track your performance. You could add metadata there so that you could also, even though if you were not logging your information in a Google Doc, you could track it from there as well. So it is very important to do lots of experiment, but in an organized manner.
That makes sense. Thanks for that clarification.
Yeah, Nikhil, please continue.
Exactly. Yeah. So yeah, the second thing was increasing number of heads, number of layers, and the embedding size, right? So again, this is just a part of highly parameterizing this transformers network, right? So I think the most important among these was the number of layers. So I think we trained a 20 layer deep this transformers network at the end. And even our number of heads, I think it was way beyond what people usually use. So we had 128 heads, as Sahil mentioned, right? But so I don't know.
One point, Nikhil. So
Yes,
if you
yes.
look at the past transformer solution, which did very good on tabular data, for example, there was this data science bowl, which was held by Booth and company, right? So there, the one of the Kagglers, Patrick Am, who performed very well in this competition also, he built a transformer only solution. And the key ingredient of that solution was he used around 32 or 64 heads, if I recall correctly. And again, like that was sort of, you could say, one of the inspiring ideas that we got, using high number of heads from, like, it was demonstrated in the past to have high number of heads.
Yes, yes. Okay, yeah. So we have talked about RE0, we have talked about dropout. Okay, so the last bit and I think one of the really interesting bits was adding 1D convolutions, right? So Sahil was insisting me at the end that we should try conformers, So conformers is basically convolutions and transformers combined. Maybe Sahil can elaborate on it a bit more. But yeah, we were quite lazy to not actually try the original conformers architecture, but what we did was we concatenated the output of each of our transformers in encoded layers uh, by using a convolution like we did similar to our front end, right? So basically, instead of just feeding the output of the current transformer layer to the next transformer layer, what we did was we also applied convolutions to the output, right? So it's basically for the next transformer layer, you are getting transformer outputs that perform the transformer plus the CNN layer outputs, right? So again, I think it was bit intuition driven and bit because we wanted to experiment. But yeah, I think this worked out really well, right? So using just this, I think we were able to skip 10 or 20 positions on the leaderboard, right? So I think, but in many of the modern architectures too, I think like if I recall correctly, Swin transformers too, they use convolutions, right? So convolutions, married with transformers, it works really well, right? So this transformer plus CNN layer gave us a really good boost. Yeah, and finally we had two outputs rather than a single output. So that was also in the last 2 days of the competition, I think. So this was again inspired from Heng CK's this PPT or whatever you call it. That's a really good diagram that we had separate outputs for inspiratory phase and expiratory phase, right? So basically all of your model is same, but your last layer bifurcates into two, right? So where you predict for the inspiratory phase separately and the expiratory phase separately, right? So at the beginning also I told that the expiratory phase values were kind of hard coded, right? So we thought that it will make much sense if we try to learn these two things separately, right? And yeah, this was also helping our model by reducing our CV scores. Sahil, you
That's
want
really
to add
helpful.
something?
Sorry, I just wanted to interrupt if that's okay. I just wanted to point out
Sure,
that
sure.
people are always asking how do researchers come up with architectures, and you could have called this architecture, you could have named this architecture after your names as well, but it's literally experimentation driven, and we're getting to learn this behind the scenes of how the architectures come about. For this, it's a data set driven problem, but I'm guessing that's also how it's for research, for a lot of research.
Yeah, most of the architectures are experiment driven. That is what they, if you again, reiterating the point I mentioned earlier, any good research paper would always have ablation studies. And those ablation studies would only highlight, like, help you highlight the point that what all component added what value. So in the end, they also, so we also had, as I had mentioned out in the beginning, that we had a set of ideas like to use LSTMs, to use GRUs, 1D CNNs, transformers, conformers. So we had all these components in our mind, and in the end we had a experiment pipelines that how we would want to experiment. And eventually, like, you keep on iterating and find some architecture that works. And kudos to Nikhil on this transformer. Like, if you read, most of the people were not able to make the transformer work, but it required some, like, a persistent effort to finally get it to work. Even in the beginning, we were not getting anywhere close to, let's say, transformer plus LSTM model. Like, our best model was transformer plus LSTM, but in the end, we were able to somehow manage this model.
Yeah.
That's helpful.
Thanks,
Thanks for.
Sahil.
So this was what the final model looked like. We trained on 15 different seeds. The CV score, as shown here, is 0.105 to 107. The number of epochs, again, this was the important bit. And this might not have even saturated in terms of learning. It could have gone on maybe till 1500 or 2000, who knows. So yeah, so this was the final model, how it looked like. Uh, and one more thing that people, which again was driven by something which Hank CK highlighted, that uh, we could see that the delta between the CV and the train was saturating. And what people started to do was train the data, just remove the cross validation part. Since now you know that the performance delta is not going to increase or decrease, both the curves were saturating. Train your model on different seeds of data, shuffle the data on the entire data set, and we could gain another, let's say, like 0.005 order of improvement using that. That is why you see that we were able to, like, if we do it on a 15 fold cross validation, the score that you would get would be of 0.105107, very similar to our CB, but the final public LB was less than 0.1. So this was the delta that we got by training on the whole data set with different seeds. Yeah. So finally, the things, like, that did not work. This is the main juice of it. I feel that by this not happening, we might not have ended up with the architecture that we have. So we tried a bunch of augmentations, like uh, how we could augment the data. We tried to add some noise to the input data set. We tried to shift the sequences a bit by, like, shifting the augmentation, and we also tried flipping it. Strangely, flip augmentation was used by one of the top solutions also, but in our case, it did not work. The important thing that we missed was the multitask training. We did it, but we did it in a wrong manner. What we tried to do was, we thought that since RNC are something that dictate how a lung would look like, and how different lungs behave, we thought that why not let the model learn this? Why not let the transformer understand the difference between the different lungs also, not only the breaths, but different lungs. Again, this did not work out as well. What people did here was, instead of using just the output pressure as your output, like the target variable, they started adding multiple different variables, like the consecutive delta, basically the delta in pressure, and the two delta in pressure, basically 2 lag shifted differences in the pressure values. Now this, if you look at the winning solutions post, like what the winners have posted, the first and the second team who had reverse engineered the data, they had come up with this concept of PID, that the data was generated using a PID controller, and it has three parts. One was the proportion part, integral part, and the derivative part. Now why this now this is again our hypothesis, and I think this is true, that why this delta, like using these auxiliary targets like delta and pressure was working, because it indicative of the derivative part of the PID.
Hmm.
And similarly, what people have not mentioned in the forum, or maybe I've missed it, is using cumulative pressure as an auxiliary target. That would have hinted towards the integral part of the PID. So most of the winning solutions have highlighted the delta in pressure, using delta in pressure as the target metric, but maybe the cumulative, using cumulative pressure as another set of auxiliary variable would also help, because that is how, like, the delta part in general, in most of the time series competition, delta in consecutive time target values generally doesn't help, but in this case it was helping. So maybe the cumulative pressure might also help. So that is something we didn't try, and this was a major miss on our part, because most of the top solutions are using multitask learning. And finally, none of the non-transform. So our final solution was a single transformer, and the reason for that was we were not able to get other architectures which included LSTM's GRUs. We tried very few experiments with original conformers, but the results were not at all close, and combinations of LSTMs and transformers. Like none of them had a CV which was as good as the transformer. So in the end, we had to chuck all this. Yeah.
That's really helpful, and for the audience, we'll also be learning from the winning team later today in like 4 or 5 hours. So you might want to join there. They had figured out how to
Yes,
reverse
yes.
engineer, how to create the data, and this was artificially generated, so they had figured out a way around it, which wasn't the goal of the competition, but that was required to win the competition, and there was a little debate around that as well. But
But the
if you're
solution was
curious to
really
learn,
innovative.
yeah,
Yeah. The solutions were really good, and kudos to the winning team. They did really good.
Yeah, so this
awesome.
was
To
it
me,
from, yeah.
I'll just try to recap quickly. So a lot of your EDA was driven by yourselves, because one thing I learned was I think yours was one of the only, if not the only, solution using a smaller sequence length.
Yeah, most of the top solutions didn't use 40 sequence length.
So I'm
Yes.
guessing a lot of your own EDA went on behind the scenes, but apart from that, you used a transformer-based architecture and a lot of experiments that led to this really strange architecture, which had a lot of parameters, really counterintuitive for a small tabular data set as well, in a way. And you could, it still wasn't overfitting, as you mentioned, because you could have trained it for longer. It took a lot of epochs. You had to really set a high value of dropout, which is also key here, and adding an inspiration from the recent swing transformer or similar architectures where you fed in a convolution based feature back into the transformer along with the learnable front end. These would be the key summaries of your solution, if I may.
Yeah. One more
Yes.
point here, like having good hardware. So what we did was we used TPUs here. We basically, for us, each experiment was running on multiple TPUs. So Nikhil, if you would like to give this advice to maybe someone who's beginning out in, like, how did we use hardware for this particular model?
Yes. So I think uh, one of the key components was definitely hardware, right? So you require good hardware to participate in Kaggle competitions really competitively. So what we did was we used Google Colab, right? So Google Colab, I think it's pretty cheap, and basically what you do is if you get a Colab Pro Plus subscription, you can train on 3 TPUs parallelly if you're using the low RAM mode, right? So basically, RAM was not a big requirement for this competition because all of our training was being done on GPU, right? So what we did was we initially we were training on a single Colab Pro machine, and we were running 3 experiments parallelly, right? So basically, yeah. One more thing that I'd like to highlight is if you can find ways to do things parallelly, it will be much it will be sorry, it will be much faster and it will really give you an edge in the competition, right? So what we did was we were running 3 say folds of the model parallelly on a single collab pro account, right? And then what we did at the end of the competition, say due to this kind of adrenaline rush that we had, we purchased 5 different collab pro accounts, right? So that we could train 15 different folds or 15 different seeds together at a time,
Interesting.
right? Yeah. So yeah, that was a bit crazy from our end, but yeah, it really helped us give us get a competitive edge at the end of the competition.
I'm guessing that's still much cheaper than what a few folks would have paid in other cloud vendor
Yes,
expenses
yes,
based
yes,
on
yes.
GPUs.
So I think it's only $50 for a month. Even Google Collab Pro Plus. Even if you have purchased 5 accounts, it's only $250. So I think for India, $250 might be a bit high, but yeah, uh, for other countries, you might think that okay, $250 is really affordable for the resources part.
For a fifth place finish, I think in India,
Yes, yeah,
this seems
it's
fine.
It's
Yeah.
very
definitely
much
worth it.
justified.
Yeah.
Yeah.
So I'll stop
Awesome.
the screen share, Sam, if that's it.
Thanks. I'll just re-ask the audience if there are any question from any one of you. I'll just give you a minute. No, I don't see any questions. I think the explanations were super crystal clear. Thanks everyone that joined. I'll quickly share my screen and point out Nikhil's LinkedIn profile. You can find Nikhil on LinkedIn. You need to change your cover profile, Nikhil, it seems.
Uh, one thing about that. So yeah, this was the first competition on Kaggle that I did really well, right? So I think I'm a bit proud of that. So that's why I want to keep continuing
Okay.
using it, even if I become a grandmaster in the future.
Sorry, I assumed you just forgot about this bit. Sorry about that.
Yes, yes, no issue.
You can also find Sahil on LinkedIn. Any other places where the audience can find you apart from Kaggle?
So I guess I'm active on Twitter, like passively active on Twitter. Just advice, like another advice which I do regularly. Twitter is a gold mine of resources. Like even though I'm not very actively tweeting on Twitter, but what I do is I follow relevant people, and they really post useful stuff. Like apart from Kaggle, Twitter is one of the major sources of learning for me. So yeah.
Exactly. So even I joined Twitter, I think only a year back, but I think Twitter is really good. If you see the threads of say if even if you follow many Kagglers, including Sanyam, and then you can find really helpful and useful links which you can study in your free times, right? So yeah, even I'm also a bit active on Twitter, not very much active. So yeah, you can definitely connect to me on Twitter or on LinkedIn, right? And feel free to shoot me a message if you have any doubts.
I would put the caveat, I'm not a good Kagler. I'm a noob Kagler who somehow manages to learn from great Kaglers like yourself. So maybe the audience would want to follow you. I'll put all of these links on the forum link I'd shared initially. And to wrap up, Nikhil, Sahil, thanks so much for joining us today. Thank you so much for giving such a detailed walkthrough of your solution. It was incredible to learn from your journey.
Thanks a lot, Sam. Thanks a
Thank
lot for
you.
having us.
Thank you, Sanyam. Thank you for inviting us. Thank you, Style. It was a